All right, now would you please try to factor these three expressions? I have x squared minus 25. I have 4y squared minus 36. Then I have 100x squared minus 16v squared. All right, pause the video and attempt those now. All right, here we go. Solutions. The first one, product of binomials x plus 5 and x minus 5. Second one, product of binomials 2y plus 6 and 2y minus 6. The last one, 10x plus 4v and 10x minus 4v. All right, those are the two binomials that we multiply together to get the factored form of the last one. All right, discussion. Watch for the difference of squares pattern. If you know how to factor a quadratic with 3 terms, go ahead and add the 0 there. Now you've got 3 terms, and you can use your skills for the 3-term factoring. All right? Whatever works for you. Okay? Now, would you please try to simplify these 3 new expressions? I have there 2x plus 2, that binomial divided by the binomial x plus 1. And then I have 7 minus x divided by the binomial x minus 7. And then last expression, I have the quadratic x squared minus 4x minus 5, that whole quadratic divided by the quadratic x squared minus 3x minus 4. All right, pause the video and try that now, please. Okay, once again, answers and discussion. First one simplifies all the way to the number 2. Second one simplifies to minus 1. The last one simplifies to the binomial x minus 5 divided by the binomial x minus 4. All right, how did I pull that off? Discussion. Factor numerators and denominators when you want to simplify rational expressions. That's what the topic here is, simplifying rational expressions. Rational expressions is essentially a fancy word for fractions, which may or may not include variables. All right, but you have to factor. All right. Once you factor, if the same factor appears in the top and bottom, then you're allowed to discard it. Okay? You're only allowed to discard pieces if you've factored it both the top and bottom, and if the same factor appears in the top and bottom. All right? Here's what I want you to avoid. Don't just remember just the piece where I said that you can discard things from the top and bottom when they're the same. All right? That's not enough to remember. Look at the end of the second bullet. If you were to see something like the binomial x plus y divided by x, don't say, oh, look, the top and bottom have an x, so I can discard it, and so that reduces to y, or simplifies to y. Okay, I'm not saying that. The third bullet has a minor point. If you see a binomial a minus b, and you want to somehow rewrite it so that it's b minus a, you can do that if you put a negative in front. Next topic. Would you please try to solve the following? I have equations now. I have the equation 7x equals 4. I have the equation 7y minus 4 equals 8 minus 5y. And then the next one, I have x divided by 4 plus 1/3 equals negative x divided by 4. And then last equation, I have x divided by the binomial 5 minus x equals 4. All right, please try to solve for x in these 4 equations now. Okay, solutions and discussion. The first equation, the solution is 3. The second equation, the solution is 1. The third equation, the solution is negative 2/3. And then the last equation, the solution is 4. Okay, discussion. When you see an equation, okay, the topic here is solving equations, you can do any valid operation to both sides of an equation at the same time. All right, think about a seesaw and think about adding or removing weight from both sides of a seesaw that's balanced. You have to add or remove the same amount from both sides to keep it balanced, right? Likewise, you can get an equivalent equation that's equivalent to the original equation if you do the same things to both sides. All right, you can add numbers to both sides, you can subtract numbers, variables from both sides, you could multiply both sides by numbers and variables. Okay, but keep doing the same thing to both sides. And then you do that until you make it you keep making it simpler and simpler until it's obvious what the solution of the equation is. All right, what would be when would it be obvious? Well, imagine if you had an equation in x and you got it simplified down to, let's say, x equals 4. This is probably the key idea of Algebra 1, the first year algebra class, okay, that most people take. All right, so make sure you understand that principle. For the last equation on the last slide, I used a technique called cross multiplying. All right, if you know what that is, great. If you don't, I would encourage you to review cross multiplication. All right, essentially what that means, that applies when you have two rational expressions, two fractions equal to each other. All right, or you have a fraction equal to an integer. All right, which of course you could make an integer into a fraction by dividing by 1. All right, but the point is, when you have two fractions, fraction equals another fraction, you can take the numerator of one and the denominator of the other, multiply those together, take the denominator of one and the numerator of the other, multiply those together, and set those products equal. Okay, that's a nice fast way to solve equations when you have that pattern, fraction equals a fraction. Okay, and then simple idea but very beneficial. When you solve an equation, okay, for goodness sakes, plug in your solutions, check to make sure that your answer is correct. It's so simple, but people often forget this. All right, if you think x is equal to some number, go to your original equation and replace x everywhere you see it with that number. Evaluate both sides of the equation, and do you see the same number on both sides of the equal sign? All right, it's so simple. All right, and that can help you, that can increase your chances of getting the correct answer so much. All right, so please don't forget that. Okay, now would you please solve the following equations? I have here x squared minus 3x minus 4 equals 0. Then I have x squared equals 7x. Then 6x minus x squared equals negative 16. And finally, x squared plus 4x equals minus 4. All right, pause the video and try those now. Okay, solutions. The first one has two solutions. That equation, the solutions are minus 1 and 4. The second equation, the solutions are 0 and 7. The third equation, the solutions are minus 2 and 8. And then the last equation, the solution, that one only has 1. That is minus 2. All right, discussion. When you are solving quadratic equations, that is the topic of this right now that we're discussing. What you want to do is you want to, first of all, you want to move all the numbers, variables, all the junk to one side so that you have a 0 on the other side. All right? So do that. That's step one. Then factor the side with all the junk. All right? So you factor the quadratic equation. All right? Now, once you have a factorized quadratic equation, binomial times binomial equals 0. Okay, If you've got that, then one or both of those binomials have to be equal to 0. That's the only way that a product could be 0, is if one or both are 0. All right. So you set each factor, each binomial equal to 0, and then that's how you get your solutions. All right. Notice you can have multiple solutions. Not You don't have to. You won't always have two solutions, but you can. All right. You may have one. You may have two. All right. Let me make a comment about the quadratic formula. Some of you may know a formula to solve quadratic equations called the quadratic formula. You don't need to know that for the SAT. If you use it, that's fine, but you don't need to. All right. What do I mean when I say that you don't need to use the quadratic formula? Because every quadratic equation on the SAT exam that you'll need to solve, you'll be able to do it by factoring. Okay? And then this is so easy and so important that I'm going to mention it again. Check your solutions. All right? This works for quadratic equations as well. You solve for your variable, plug it in. Does it really satisfy the equation? Okay?